All right, so let's take a look at another conservation of momentum problem. And so this is actually, a fairly simple problem. We're going to say that we have a bullet and that this bullet's traveling to the right with some velocity v bullet. And we know that the mass of it is mass of the bullet. And then let's say we have a block, and this block is on a frictionless table, and it has a mass of the block. Okay, and it's initially at rest. Okay, and then at some time later, the bullet's going to collide with the block. It's going to become embedded in it, and then the whole system is going to be traveling to the right. Okay, and so the question is, find the final velocity. Okay, so this is a problem that's pretty easy to set up. We take, again, we use the conservation of momentum, so we have the mass of the block times the velocity of the block, and this is all of the initial momentum, right? This is our initial momentum. We set it equal to the final momentum. So now we really just have one object here, and it has the mass of the block plus the mass of the bullet, and then that's times multiplied by the final velocity, and this is the final momentum. So all we do is we just divide by the combined mass and see that the final velocity is just the mass of the bullet divided by the mass of the block plus the mass of the bullet times the velocity of the bullet. Okay, so we check our units. So we want a velocity. We have a mass times a velocity divided by a mass. So the units check out. And now we check whether or not it makes sense. So initially we have a velocity of the bullet. Our final velocity is the velocity of the bullet times the mass of the bullet over the mass of the bullet, the block plus the mass of the bullet. And we look at this fraction and we see that the denominator, right, is bigger than the numerator. So that means that this is going to be something less than 1. So in other words, this is telling us that our final velocity is less than the initial velocity. And that makes sense, right? That's exactly what we would expect. Like if the bullet's moving at one velocity, and then basically in this collision you can think of it as picking up mass, then we would expect for its momentum to be conserved, that the final velocity is going to be slower. So this also makes sense. And so that's how we would solve a problem like this.